Hello crafters, welcome back to Code Crafters. In today's video, we're diving deep into nested loops in C++. If you've ever struggled with loops inside loops or wondered how they work, you're in the right place. By the end of this video, you'll not only understand nested loops but also be able to use them confidently in your projects. Let's get started. So, what exactly are nested loops? A nested loop is simply a loop inside another loop. The outer loop runs first, and for every iteration of the outer loop, the inner loop runs completely from start to finish. This structure allows us to repeat a set of instructions in 2 or more dimensions. Think of them as layers. The outer loop controls the broader structure, while the inner loop performs more detailed tasks within each iteration of the outer loop. For instance, if you're working with rows and columns, the outer loop could represent rows, and the inner loop could handle columns. It's like navigating through a grid or matrix, one step at a time. Remember, for each iteration of the outer loop, the inner loop executes completely from start to finish before moving on to the next iteration of the outer loop. Here's how it works step by step. The outer loop starts and executes its first iteration. The inner loop then begins and runs all its iterations. Once the inner loop completes, the outer loop moves to its second iteration, and the inner loop resets and runs again. This process continues until both loops have completed their specified number of iterations. Nested loops are powerful because they allow us to repeat tasks in 2 or more dimensions. Nested loops are widely used in real-world scenarios. Here are a few examples. Grids and matrices. Whether you're processing a 2D array or working with spreadsheets, nested loops help you navigate rows and columns. Patterns and designs. If you've ever created star patterns or pyramids in programming, nested loops are the backbone. Game development. They're used to render grids like chessboards, battlefields, or pixel maps. Mathematical operations. Tasks like generating multiplication tables or performing matrix multiplication rely heavily on nested loops. While nested loops are incredibly useful, there are some important points to keep in mind. Complexity. Nested loops can make your code harder to read if you're not careful. Always use meaningful variable names to keep it clear. Performance. The number of iterations grows quickly with nested loops. For example, if your outer loop runs 100 times and the inner loop runs 100 times, you're looking at 10,000 iterations. This can slow down your program if not optimized. Avoid overnesting. If you find yourself using 3 or more nested loops, it's a good idea to rethink your approach and see if the logic can be simplified. Break and continue. You can use break and continue statements to manage how nested loops run, such as skipping iterations or exiting early. Let's move towards the 3 types of nested loops. First loop is the nested for loop. So, what exactly is a nested for loop? Simply put, it's a for loop placed inside another for loop. This allows us to create repeated processes in multiple layers. The outer for loop handles the broader task, and for every iteration of the outer loop, the inner for loop completes its entire process before the outer loop continues. For example, if you think about rows and columns, the outer loop might control the rows, and the inner loop takes care of each column in that row. Once all the columns are processed, the outer loop moves to the next row. This is the core idea behind nested loops. After that we have nested while loop. So, what exactly is a nested while loop? Simply put, it's a while loop placed inside another while loop. This allows us to create repeated processes in multiple layers. The outer while loop handles the broader task, and for every iteration of the outer loop, the inner while loop completes its entire process before the outer loop continues. For example, if you think about rows and columns, the outer loop might control the rows, and the inner loop takes care of each column in that row. Once all the columns are processed, the outer loop moves to the next row. This is the core idea behind nested loops. Lastly we have nested do-while loop. So, what exactly is a nested do-while loop? Simply put, it's a do-while loop placed inside another do-while loop. This allows us to create repeated processes in multiple layers. The outer do-while loop handles the broader task, and for every iteration of the outer loop, the inner do-while loop completes its entire process before the outer loop continues. For example, if you think about rows and columns, the outer loop might control the rows, and the inner loop takes care of each column in that row. Once all the columns are processed, the outer loop moves to the next row. This is the core idea behind nested loops. What makes do-while loops unique is that they always execute at least once, as the condition is checked at the end of the loop instead of the beginning. This ensures that both the outer and inner loops run their tasks at least one time before evaluating their conditions. Understanding nested loops will open doors to more advanced concepts like working with 2D arrays, recursion, and algorithm optimization. Master this, and you're well on your way to becoming a stronger programmer. Thank you and happy coding.